Welcome back, fam. This is Mr. James, the decomposer and the synthesizer of math and science tutor. Guys, as I always say, if you're not okay, if you're not good, do what? Take one day at a time. Now, but for today, I would like us to focus on what we call inequality, right? We're going to be focusing on some of the basics of inequalities. So, a lot of people do not understand the difference between an equation and an inequality, okay? So I would really like to differentiate between the two. That is the main goal of today, and just to touch up on a few problems regarding the inequalities, okay? So how am I going to be able to identify the difference to identify these two things, inequality and an equation, okay? Guys, for example, you're given 3x equals to 9, or you're given 3x plus 1 equals to 2. You have 3x plus 1 equals to 2. There is an equivalence there. The minute you have the equivalent, you must know equation comes from the word equal comes from equal. They correspond. Equal, equation, equating things, meaning they must be equal to those things, you know what I'm saying? Equivalent, you know what I'm saying? So, in other words, when you're dealing with equations, you have to make sure that the left-hand side equals to the right-hand side, or the right-hand side equals to the left-hand side, okay? So that you don't forget, left-hand side equals to the right-hand side. Right-hand side equals to the left. That's the song that you must always think about whenever you're dealing with equations. So after solving an x, solving for a y, you take that value, substitute it back to check if the left-hand side equals to the right-hand side. If they're not, there's an error. You have to rectify that. Good. Now, let's try to work with this guy. It's an equation. And I'm going to prove it to you that the both left and right must be the same. Now, if I have 3x plus 1 equals to 2, Mr. James, the decomposer, help me out. Now, this is what I'm going to do. Before you solve this guy, you got to check something which we call the like terms, okay? Now, what are the like terms? The like terms are basically the terms that are the same. You get what I'm saying? Could be a constant with a constant, variables with variables, coefficients, and you get what I'm saying? So now, I see 3 as a coefficient of x plus 1. 1 does not have a variable or a letter. So does the 2. So these are constants. Since these ones are constants, they don't have letters. They tend to be what? Like terms. Okay. But if this guy was x, do you see that these two, they're the same? So I was going to take this guy and make sure that I group him with 3x. But because he's just a number without a letter, he's a constant, then I can do what? I can group him with Mr. 1. So I'm going to transpose 1 to the other side. And since this is an equal sign, an equal sign represents a bit of transformation, because the moment you shift from the left-hand side, you go to the right-hand side. You change from left to negative, from positive to negative, or from negative to positive. That's what happens. So this guy is positive. When you go to the other side, when I'm going to, look what I'm going to do. I'm transposing this guy to this side. So I'm going to end up having what? 3x equals to 2 minus 1. Why is it negative? Remember, he's positive. When we transpose him, it's going to become negative. If this guy was minus, obviously this guy was going to become the plus. Making sense? Good. But it's a plus, so I have to make him minus, and then the answer is going to be 1. I have 3x. Now, this is where the problem starts. Someone is going to get stuck just because of they have arrived here. My people, you have 3x, and you're not looking for 3x. You're looking for who? For the x. So what must I do with this, Mr. 3? Every time when you have a number multiplied by a letter, you have to divide both sides by that letter. What is my point? My point is to say 3x divided by 3 equals to 1 over 3. What have I done? Remember the law of math. Whatever that you do on the left, you must also do on the... So 3 cancel out with 3, then x equals to 1 over 3. Guys, I can prove it to you. If I plug 1 over 3 here on this x, and it does not give me the answer, which is 2, I resign. You can unsubscribe, you can unfollow me on every social media. Let's check. Let's check in my future. Let's check in. So I'm going to have 3 into 1 over 3 plus 1 equals to 2. Okay? So it's a multiplication. It's like 3. Basically, it's going to be There are two ways to do it. You can take a calculator, but 3 cancel out with 3, then you're left with 1 plus 1, which equals to 2, and 1 plus 1 equals to 2 equals to 2. So you see that both sides are equal. It's to show that we are dealing with an equation. But if I start to get into what we call an inequality, there is an imbalance there. There's an imbalance. Our balance here, you understand? So that's where the problem is. One has to be bigger, one has to be less. But we gotta fix that guy. Don't worry. Let me show you. Alright. So guys, check it out. There is this sign which you call less than. You see, when you see this sign, this guy we call him less than. Less than. When you see this guy, greater than. Greater than. Greater than, less than. So this guy less than means small. It is small fish, but it is big fish or born. It is kataka. And then you can also have less or equal to. So we have less or equal to. We call this guy less or equal to, and then we also have this guy whom we call greater than. Greater than, or we can say greater or equal to. Yeah, greater or equal to. So whenever you see a greater with one line like that, greater or equal to, that's what we say greater or equal to. So it means that value can be greater or it can be equal to that x. This less, that value could be less or equal to the x. This guy has to be greater than x. This guy has to be less than x. You get? So these are the different signs that you're going to come across in inequality. So whenever we have expressions, for example, you see, let me just say it was plus, plus, okay? So these two guys, we call them expressions. The minute I put this guy, he is called an equation. The minute I put this guy, he is called an inequality. Do you see the difference? I hope you do. Then now, let's deal with these people. Whenever you see less, when you see this guy, this sign of less, these are the type of brackets that you must use. Remember, under inequality, you need to know what we call a set builder notation, interval notation, and a number line. So this is a number line. So now I'm going to show you whenever you have this less than on expressions, basically you're going to have these brackets. Okay, you're going to have soft brackets like this. I call them the soft brackets. They are curved. So be curve at the border. And then now be greater, this guy be greater. Oh, we are not cycling the same thing. So when these two guys are always having the but overly curve, but curve. But actually concave up to concave down, and but actually curving about the ball. Yeah, la dala ball on monorai ra miss bola, I actually free kick your then now you have less or equal to. Less or equal to, the brackets are different. So these ones, they are square brackets. It is square bracket. Same applies to this guy. It is square bracket. So whenever you have less or equal to or greater or equal to on an expression, your interval notations always use this square brackets. But whenever you have a less than or a greater than, always make use of what? These soft brackets or the curved brackets. Awesome. Then now, I'm going to show you guys something. Whenever you see this guy, we call them the excluded. Even this guy, which are excluded. Whenever you see the less or equal to, greater or equal to, this guy are included. Included. So I'm gonna show you guys something. If you have a number line here, basically if you have a number line, and then this is 0, okay, minus 1, okay, 1, you have something like this. It goes that direction. We are looking, it means this guy, it's the values of x that are greater than 1. Then we're looking for the values of x that are greater than 1. Excluding 1 because of it's not shaded. In other words, whenever you're dealing with less or greater, here we unshade. 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 We don't shade the values on the number lines whenever we have these two signs. But when I have the less or equivalent to, the greater or equivalent to, I'm gonna do what? Shade. You see, we have shaded. It means we're dealing with one of these two guys. Here, it's unshaded. It's one of these two guys. It's shaded. It's one of these two guys. So whenever on the number line you see those values are shaded, it means we're looking for those values that are greater or less than, including. So in other words, here, I'm looking for all the values that are bigger than 1, excluding 1. That's why we had to unshade, because they say these guys are excluded. But the minute I shade it, then it means I'm looking for all the values that are greater than 1, including 1. So that's what happens, guys, when you deal with inequalities, okay? So, let's check. When I have this guy less, or I have this guy on the number line, okay? Maybe let's just say this is 1 minus 1 and 1, and then you have something like this, okay? So you can see here it's 0, okay? So we are looking for all the values that are between minus 1 and 1. So this is how we're going to write it. We're going to say x is bigger than negative 1 but less than 1. Whoa, that's x. X is bigger than negative 1 but less than 1. And one thing you should understand is that we are looking for all the values that are in between minus 1 and 1. We exclude minus 1, we also exclude 1. That's why they are unshaded here. Okay, but immediately when you see the shaded, these guys are shaded, then it means I'm going to do what? Put it like this. Then what do I say? X is greater or equivalent to negative 1, but x is less or equivalent to 1. So in other words, we are looking for all the values that are in between negative 1 and 1, including the minus 1 and 1. That's what happens. So this is what happens whenever you're dealing with these two signs. I hope you get it. And then, let me try to deal with this guy. So I see bigger, greater than, and I see greater or equivalent to. So I can have this guy going there, I can have this guy going there, okay? So I'm going to say x is greater, x is less than negative 1, or x is bigger than 1. Okay, what happens here is that we're looking for all the values that are greater than 1, excluding 1. X is greater. Here, x is bigger than 1, excluding 1. It means I'm using this side, greater. Okay? X is less. Here, we're looking for all the values that are less than negative 1, excluding it. We don't include it. But immediately so all these two guys, they're going with the greater sign, okay, of the inequality. This inequality sign is for these two guys. But immediately when I shade, then I'm going to be having what? This guy. He's present on that expression. They will be putting this guy. So we say x is less or equivalent to negative 1, or x is greater or equivalent to negative 1. In other words, we're looking for all the values that are less than negative 1, including negative 1. We're looking for all the values that are greater than 1, including the 1. Making sense? Okay. Then now, let me try to solve a few problems with you guys, okay? So I have this guy, alright? You need to solve this inequality. How do you solve it? Guys, when you're solving an inequality, is the same way when you're dealing with an equation. The only difference is that one has to be bigger, one has to be less. There is an imbalance there, okay? So let me see. We're looking for who? For x. What must I do? I must divide both sides by 3. So I'm going to have 3x divided by 3 equals to 9 divided by 3. And then x, it's still less than. So x is going to be less than what? 9. How many times that? So it's going to be 3. So x is less than 3. If x is less than 3, how am I going to represent this guy using a number line? So I'm going to be having this guy. So I can have 0, negative 1, minus 2, 1, 2, and 3. I can extend it a bit and add 3 there. So x is less than 3. X is less than 3. X is less than 3. So take this guy, go there. X is less than 3. We're looking for all the values that are less than 3. All the values that are less than 3 are gone. Excluding the 3. 3 is not included. But if it was like this, that's how you write it. How am I going to represent it on the number line? I shade it. So I'm going to say x is less than, all the x is less than 3, including the 3. So basically we're saying x is less or equal to 3. X is less than 3 or it might be equal to 3. You get? So all the values that are less than 3, including the 3. So in other words, we are also including the 3 here. Okay? So that's what happens whenever you're dealing with this. Oh no, my apologies. My apologies. I'm gonna show you guys something, but it's fine. Yeah. But that's what happens there. Okay? So I wanna show you something important, Buffett. Here. On this number line. Ne? So we're going to make use of the interval notations. Ne? So let's represent this guy using interval notation. Like you can see here, it's 0, 1, 2. So minus 1, minus 2. And then it goes until infinity. It goes until infinity. Like it just goes until infinity. So how am I going to do this guy? Since it's included, what kind of brackets must I use? The square bracket. So I'm going to use this guy. So it's negative 2. I'm going to say negative 2 and infinity. So negative 2 until positive infinity. So we include all the values that are greater than 2, including 2. This guy, since he's excluded, it's soft brackets. Since he's included, square brackets. Now 0, 1, 2 is minus 2, and then 0, 1, 2, 3 is 3. So in other words, you're looking for all the values that are between minus 2 and 3, including 3, excluding minus 2. So in other words, we're looking for all the values that are less than minus 2, but minus 2 is excluded. And then until positive 3, the 3 is also included. So that is how we show the interval notations of these different number lines of inequalities. Now on this guy, I'm gonna be having, since they are both included, so I'm gonna be having the square brackets. So check this guy now. This guy is going to be 0, 1, 2, minus 2, and then 1, 2. So it's minus 1, positive 1 is 1. So we're looking for all the values that are less than negative 2, including 2, or values that are bigger than 1, including the 1. So this is how you represent this guy using interval notation. If you were to use a self-builder notation, this is the one which they use. X is an element of all real numbers, and X for that one. Your X is basically less or equal to. Oh, so your X is basically greater or equal to who? Who's this guy? Minus 2. That's how you can write it down. And then the other one, X is an element of all, or we can just write it like this, it's fine. We can just write it like this. This guy is just going to be X is greater or equal to negative 2. Whenever it's going there, it shows it's greater, because it's going that positive directions. And then this guy, since you can see, whenever the two values are connected, it's always this guy, less or equal to. Okay? So let me show you. In other words, here I'm going to have X. It's between what? Okay, let me remove this guy. He's going to be minus 2, and this one is going to be 3. Now let's check some. Every time, look guys, every time you see these two values, they are connected, always know that it's always the less than, X is always in between the two values. The one that is small, X must be bigger than it. The one that is positive, X will always be less than that value. So in other words, X is greater than negative 2 but less than 3. But since here this guy is unshaded, we are fine here. Since this guy is shaded, I must put this guy. So they match, you see. Excluded, so that the brackets. Included, so this is how we represent these people. This one is going to be X is less or equal to negative 2, or X is greater or equal to 1. They are both included. X is less or equal to negative 2, or X is greater or equal to 1, including the negative 2. But if these guys were not shaded, they were empty like this, they were empty, I remove this guy. See? So that is how it represents them. And then in terms of the brackets, they will all be soft brackets. The curved guys, the curved people. So this is actually how it represents these people number line in terms of interval notation and set builder notation. Ne? So this is the statement. These are the statements you can actually say. X are all the elements of all real numbers and X is That's how you say it. Ne? In other words, X is an element of all real numbers and X is greater than negative 2 but less than or equal to 3. That is how you say it using a set builder notation. Okay, someone will put it like this. X is such that X is an element of all real numbers and X is greater than negative 2 but less than or equal to 3. So this whole thing is a set builder notation. I mean, it's your another statement. But because of when bracket is simple, it is nice. When you're given a number line, set builder, your interval notation, then that's your statement. Since these people were shaded and give you square brackets like that, so I'm just gonna put it like that, and this is how you show this type of problems. Ne? I hope this was not difficult, guys. Ne? Okay, so let me try to do something else now, something different. Let me try to do something different with you guys. Okay, maybe you might have something like this. X squared minus 4 is less than 0. Okay, how am I going to solve this type of a problem? You want to solve this type of a problem, what you gotta do is basically to ensure that you factorize this guy. Ne? So let's try to factorize. You can see this is like the difference of 2 squares. So I'm going to have x minus 2 into x plus 2. All they must be less than 0. Then I have something called the critical values. But for now, I will leave it. Okay? Since it's less, we are looking for the values that are in between. Every time when you see less or less than equal to, those values are always in between. X is always in between the two values. Ne? So this is what I'm going to have basically. It means x minus 2 equals to 2 or x, sorry, not L, but we use and since they are less. And x plus 2 is going to be equal to 0. Since this is 0, and then x equal to 2, and then here x equal to minus 2. Okay, this is not really what they're looking for, right? So this is what they're looking for. You're going to say since your x is 2, the other one is minus 2. X, we all know that is less than. We're looking for all the values that are in between. Ne? And I told you that whenever you have a negative and a positive, the one that is negative, x will always be bigger than that value. Okay? So x is bigger than negative 2, but less than 2. Because of all of the values are less, so I'm going to put it like this. So this is the final statement of how to solve this guy. But then you need to also represent this guy on a number line. Okay? So let's make use of a number line. So it's 0, 1, minus 2, minus 1, 1, 2. So let me represent this guy as this guy, and then the 2 is there. Since the x is in between, we connect the two guys. And then do I shade? No. This is the final answer. So this is how you show this type of people. If it was like this, obviously you know I'm going to put it like this, and then I'm going to shade, then I'm done. That's how you represent these two people. I hope it makes sense. Okay? Now let's check if ever this guy was greater than 0. If it was greater than 0, still the same thing, factorize x minus 2 into x plus 2, all greater than 0, and then x minus 2 equals to 0, and, oh no, we can't say and because of it's greater, we use or in this case. Or x plus 2 is greater than 0, oh no, it's equaling to 0, and then you can have x equaling to 0, oh no, you 2, or your x equaling to minus 2, okay? So the main thing after this step basically is to say, since they are all greater than, we're looking for all the values that are bigger than 0. Since this guy, 2, is 0 bigger than 2, it means x here is less. Guys, it should make sense. People are expecting me to say x is bigger than minus 2 or x is bigger than 2. No, I'm not going to write it like that. You know why? Because this guy tells you x squared minus 4. We're looking for the values of this function whenever it's bigger than 0. What are the values of x of this function? that are bigger than 0, that are greater, that are positive. That's our main focus. We're looking for the values that are positive, that are greater than 0. So x cannot be bigger. It's not bigger than 0, this guy. He's less than. So we have to make this guy to be what? Less, because x is less because of its minus. But if it's positive, x is greater because we're looking for all the values that are bigger than 0. I hope it makes sense. Now, let me show you how to do this guy. You want to say x is less than -2 or x is bigger than 2. That's how we show this guy. From here, that's your final answer. But you can write it like this so that you don't have problems. But the main thing that they're looking for is to factorize. You have this guy, and then from there show it on a number line, and then you could have -2 and +2, and then now do I connect the two? Look, and means you connect, or means everyone goes, gumba uyakwa. When ufunela watu yako uyahamba uyangale. That other one uyangale. Remember, we're not looking for the same thing in life. You get what I'm saying? So you go that way, I go that way. That's how it is. If we're all in the same direction, then it is that way. But then now check. Since I need less than -2, rumisha kwa or bigger, rumisha kwa. Now check out something. They are all greater, They are all greater. So it means we don't shade. So we leave it like that. But if it was greater or equal to, this is how we're gonna put it. X is less or equal to -2, x is greater or equal to +2, then I shade. So I'm looking for all the values that are bigger than 2, including -2. I'm looking for all the values that are less than -2, including the -2. I'm looking for all the values that are bigger than 2, including 2. But if they are unshaded, if we didn't shade here, it means we're looking for all the values that are bigger than 2, excluding 2. Okay? And then using the interval notation, this is going to be -2 and 2. Okay? But if they were all like this, we use soft brackets. Okay? So this is how you actually do this to people. So I hope you were able to understand these few things that I was trying to do, guys, trying to show you. I didn't matter. So let me try to do this few examples that sometimes you might have something like this. Let's remove this guy. Sometimes you might have 1 by 5x plus 10 less or equals to 0. How do you solve this type of a problem? Remember, are these two guys like terms? No. What must I do? Take this guy to the other side. 0 is also a number. Come on, guys. People tend to think that 0 is not. 0 is a number. And 0 exists in each and every number. Like 1. 1 is just not like this. It's 0, 1, 0, 2, 0, 3. So in each and every number there exists 0. People tend to think that 0 is nothing. That's why people don't even believe in God. But guys, God is there, you know what I'm saying? And I take God is like 0. He exists in each and every number. Whether that number is negative integer or is a positive integer, God is there. And that's why everything that shifts as a graph, it always shifts along the origin. The origin is what? Where you find 0, that's where you find God, the center of everything. Every number, let me just minus, it's fine. And then lastly, to show that God is indeed 0, according to me, is that you can take any number. Just say 1,000 or a million divided by 0 is going to say undefined maths error on your calculator. You know why? You cannot divide God. You can't, but God can divide you. And when He divides you, because of your creator is the source. 0 divided by 4, 0. 1,000, 0 divided by 1,000, 0. Let me minus. So God is there. I'm just telling you, God is there. Believe. Have faith. Now, let's try to solve. I'm having 5x, and then I take this guy to the other side, I transpose, then it's going to be less or equal to -10. Now, let's divide these people by 5, because we're looking for the x. So I'm going to have 5x divided by 5 is less or equal to -10 divided by 5. X is less or equal to -2. So that is my final answer. X is less or equal to -2. Then you are done. So on the number line, 0, Negative 2, it goes there. You shade because of it's like that. You shade. I shaded. Now, if ever this guy was just like this, it means I'm gonna leave it like that. It's unshaded. I hope we are good on that part. Ne? Awesome. Then now, I want to share to you guys something important, ne? Which people might not be aware of. Guys, what if this x was negative? What if this guy was minus? You see, minus 5x plus 10. Let me show you how to do it. Don't try to say, let's divide both. No, relax. Take it easy. You're going to say minus 5x. You take 10 to the other side. It's less than or equal to 10. It's negative because of it was positive. You know how it works. And then from there, we need to divide both sides by negative 5. Now, this is a different story because of the negative 5 does not only affect the 5, but it also affects the x. And according to the rules of inequality, whenever the x is negative, it's going to affect the inequality sign. So if we had negative x less than 4, remember, you must make this guy to be positive. X is going to be bigger than minus 4. Do you see what happened? When I divide both sides by negative, the inequality changes from less than to greater than. This guy will change from positive to negative. Okay? I hope you see that. But what if then it was negative as well? Oh, it was still going to be x is bigger than 4. You divide by negative, negative is positive. That's what happens. What if then this guy, he was like this, greater than negative 4? What is going to be the answer? Since it's greater, the x will now become less than positive 4. Okay? If it was like this, what happens? The x is negative, we divide, this guy changes from less to great from greater to less than negative 4 because it's positive. So these are all the changes that takes place whenever the x is negative. These are the rules of inequality. So make sure that you don't do those mistakes. And then from here, I'm going to have minus 5x divided by minus 5. Now, because of this guy, he is affected by this guy, he's going to change to greater or equal to negative 10 divided by minus 5. Then x is greater or equal to positive 2. So how do we write this guy down? He's 0, 1, 2. He's 2. Then we go that direction because it's what? Greater. So we're looking for all the values that are bigger than 2. Since it's included, shade it. That's what happens. I hope you are not sorted in terms of how to solve an inequality and to show that number line there. Okay, no matata there. Okay. Let me try to do this one. So now I have number 2. Okay, let me just write it here. Number 2. It's 2 is less or equal to minus 3x minus 1 is less or equal to 8. Okay, so we are having this guy now. How do you solve this type of a problem? Okay, how do you solve this type of a problem? Now, this one, what you need to do is to firstly remove the minus 1. Okay, you can see here everything is sharp. Whenever what you do, remove the minus 1 first. Now, here's a problem. My people, when you remove the minus 1, you must make sure that the minus 1 goes to the 8. It goes also to the 2. Everything must be balanced in this case. So we're going to say minus 3x is less or equal to 2. When it goes to the other side, because of its negative, it's going to become positive 1. And then less or equal to, since it's negative, when it goes there, positive 1. So this is 9. And then this will give me 3. 2 plus 1 is 3, 8 plus 1 is 9. We are not looking for minus 3x. No. We are looking for who? For x. What must we do? We divide both sides by minus 3. So I'm going to have 3 divided by minus 3. Since the x is negative, the sign is going to change now. This guy must change. This sign must change. This guy must change. Who affected Lukamuka? So it's going to be that x, and then this guy also changes to 9 divided by minus 3. Obviously, now you can see x is basically greater or equals to minus 3. And then here it's going to be, it's negative 1. which is like that now. So you can see -1 is bigger or equal to x. X is also bigger or equal to -3. So this meaning -3 is less or equal to x. And x here is less or equal to -1, which makes sense. Between -1 and -3, who's bigger? -1. Let me use a number line. If you use a number line, you can see this is your 0, your -3, and your -1. Okay? So you can see that -1 is closer to the positive side. So it has to be bigger. You see, it has to be bigger. So we said x must be bigger than -3. So it goes there. -1, it must also be bigger. So they are all going that direction in a way. If I have to draw them nicely, I can draw it like this. It's your -3, I can write it like this. It goes that direction, or your what? Or your -1, and I must shade. Okay, so you can see x is less than x is less than -1. My apologies. I got x is less or equal to -1. X is less in this case. So since x is less, so it means I must write it like this. Didn't see that. So it's -3 and your -1. X must be less. X must be less than -1. But x must be greater than -3. So it means this one must go there, and then this one I can put it here, it can go there like that. So I shade. Because x is less. All the x is less than -1. I'm focusing on the values that are but you get the point, né? So this is actually how we basically solve the inequality of this type of a problem, in case it comes. But this is how you solve it, né? No problem. I can do the last one. These are just simple basic inequalities of linear, né? These are not the quadratic ones. What if I have this guy? He is 1/2 into 2x plus 8, close the brackets, less or equals to x minus 3. How do I do this one? The last one is this guy. It's -1 is less or equals to -2x plus 1 divided by 5, which is less or equals to 3. Okay, I'm gonna start with this guy, man. This one is easy. What you need to do is to break down the fraction by cross multiplying both sides by the denominator. So I'm gonna have -1 times 5 is less or equals to -2x plus 1 is less or equals to 3 times 5, which is gonna give me 15. So basically it's like I have 15 less or equals to 1 minus 2x plus 1, which is like that, -5. Making sense, ne? Then take the 1 to the other side. So we're going to have -5 minus 1 is less or equals to -2x is less or equals to 15 minus 1. Because it's positive, when it goes there is minus, and then your final answer, I remove this guy, it's going to become -6 here, it's going to become 14. Then you're looking, remove this guy. Then we're looking for what? For x. How must I get rid of -2? You divide both sides by -2, ne? So your final answer is going to be -6 over -2, which is now the x, this guy changes like that. Your x is also changing, this guy is going to look that direction, and then you're going to have 14 over -2. Our final answer. Our final answer of this guy is basically 3 greater than x or equals to -7. So this is going to be the final answer of how to solve this inequality. Okay? And then you will do the rest in terms of doing this kind of number line. This simply means x is less or equaling to 3. But x is greater or equals to minus 7. So on the number line there, you can have 7 here, your 3, you could have your minus 7. So you shade, you also shade. Ne? Since x is bigger, 3 is greater or equals to x, meaning x is less than. X is less than. So all the values that are less than there. And then this guy is bigger. All the x is bigger than you get it. So this is how you're going to show it on a number line. Okay.